Welcome to this week's research overview, and we're talking about multiplication. Did you know that 30% of 8th graders are proficient in math, and the biggest foundation is multiplication? Why is that, and what should we do? So let's check this out. I'm Jonathan Brunfer. I'm a researcher, teacher, been in classrooms kinder through 9th grade, and my entire staff goes in every single week working with teachers and kids just to get a vast amount of knowledge about how we can just decrease all the clutter in our classrooms and get kids to really understand mathematics. Okay, so we're going to jump into multiplication. Can you name the 5 most effective models? And also, what is the number one misconception with multiplication? Okay, so the misconception, we'll jump in there first, is that when you multiply two numbers, you always get the product that is greater than both those factors. That is not always true when we're dealing with decimals and numbers that are less than 1. Okay, what is multiplication? Well, if you remember back in school, it was multiplier times the multiplicand equals the product. A lot of times now we're actually not even using the words multiplier and multiplicand, which I actually love. We're just using the words factors. Factors are important. With a product, you want the two factors divide into that product evenly with no remainder. So that's what the factors are. But multiplier, multiplicand, the multiplier actually comes from the word iterate. So iterate means to copy. So I like when we're talking about the multiplier, yep, we're gonna iterate it over and over again, and the multiplicand is some type of unit. So we can think of the first model is the number line and or bar model. I like using the bar model initially. So if we're talking about 2 times 5 or 5 times 2. So commutative property, they both are 10. However, if you're thinking about the multiplier and the multiplicand as the iterator and the unit. So 2 times 5 would be 2 iterations, 2 copies of the unit 5. 5 and 5 is 10. But 5 times 2 would be 5 iterations of 2. 2, 2, 2, 2, 5 2s, and you still get 10. So in all real life situations, in visual models, a 5 by 2 and a 2 by 5 are different, but the product's always the same. So that's the first model, is having that bar model and number line. And that actually leads into skip counting, both forward and backwards. And that usually is around 2nd and 3rd grade. Check out our other research overviews on why should we introduce a linear model first before an area model. Part of it's that 1 dimension, 2 dimensions. So that 1 dimension with the number line and the bar model, then we move to the area model, which has 2 dimensions, and then we can look at larger products, especially when we have numbers greater than 10, like 12 times 15. So we want to be able to take 12 times 15, we're going to have 12 iterations of that 15. So we might go, oh, well, let's do that 12 10 times and then 5 times. And then you have that area model, which actually has a visual, and that visual actually helps us conceptualize what a product is. That actually leads into algebraic understanding and when you're doing quadratics later. So that's another story, but this is the foreground for that. Okay, then the next one is the ratio table. It's just a table that is multiplicative. And so what we want to be able to do is we could say, oh, go back to the 12 times 15. We could say I have a unit of 115, and then we could do a 1, 2, 5, and 10 table. So what is 2 15s? 30. What is 10 15s? 150. What are 5 of them? 75. And then you can look for the different products. So the ratio table is a really flexible way. I call it a flexible algorithm, and it really helps us build proportional reasoning. So those are the first 3 models, the number line bar model, we have the area model, and the ratio table. Okay, the 4th one then is partial products. Partial products really ties in nicely with the area model because you can do all the different partial products. So if you did 12 times 15, you could do the 10 times 10, the 2 times 10, the 5 times 10, and the 2 times 5s. And then you visually see all those different partial products. And that leads into this distributive property later on as well. So that is a really nice one. And then that leads into the 5th one, which is our standard algorithm. Our standard algorithm is much more efficient. It has very little space, but there's some inefficiencies with it. We allow for some mistakes, and it doesn't always build conceptual knowledge or flexibility with multiplication. So all 5 models are very important to have, and I like to be thinking about it as a progressive formalization. So we are going to progress in formalization of that number line with the area model, ratio table, partial products, and then the standard algorithm. So if you're thinking of introducing this around 2nd grade, building on them, they're all so useful until you get to the standard algorithm, sometimes right around 5th grade. So that gives you a little bit of understanding about what multiplication is and the 5 main models. And so if we can build that, then we have a better conceptual understanding. We can actually apply multiplication to multiple situations in school and outside of school, and we can increase our kids from 38% proficiency on the NAEP to 40, 50, or 60% in the next few years. So if you have any comments, go ahead and leave those below. Check out our teacher tips on all of these examples this week, and please like and follow us.